Welcome to the mathematics in my channel. Today we are going to solve another interesting integral. Integral from 0 to pi over 2 natural log of cosine of x times square root of natural log of sine of x over tan of x dx. Well, how to begin? First I am going to take this integral is equal to I, and then we can write this is equal to integral from 0 to pi over 2. Now 1 over tan of x, we know cot of x, so here cot x, then natural log of cosine of x, the square root of natural log of sine of x dx. Okay, then we can take a substitution. So if we take u is equal to natural log of sine of x, then differentiate, so du is equal to, now we know derivative of natural log of sine of x, 1 over sine of x times, according to chain rule, we know derivative of sine of x cos x, so cosine of x over sine of x, we know cot of x dx. And also here in this equation we can isolate the sine of x, so sine of x is equal to e to the u, and here we have cosine of x, so we can isolate the cosine of x. We know cosine of x is equal to the square root of 1 minus sine square of x, so 1 minus e to the 2u. Okay, now here we can plug in. So now lower limit when x approaches to 0, we know u approaches to minus infinity, here 0. Now natural log of cosine of x, so we know natural log of cosine of x is equal to log of the square root of 1 minus e to the 2 minus u, and here natural log of sine of x, we know u, so square root of u, here cot of x dx, we know du. Okay, then we can write this is equal to here we know 1 minus e to the 2u to the 1 half we can write outside of the integral sign, so 1 half integral from minus infinity to 0. Now square root of u times natural log of 1 minus e to the 2u du. Okay, now we know natural log of 1 plus x we can write as a series, so we can write this is equal to infinite sum n is equal 1 to infinity minus 1 to the n minus 1 x to the n over n. Okay, now we should find the natural log of 1 minus e to the 2u, so instead of x now we can plug in e to the 2u, so we can write natural log of 1 minus e to the 2u is equal to infinite sum 1 to infinity minus 1 to the n minus 1, here minus e to the 2u to the n over n. Okay, now we can simplify, here infinite sum n is equal 1 to infinity, now here we have minus 1 to the n minus 1, here minus 1 to the n, so we can write minus 1 to the n minus 1 plus n, so 2n minus 1 e to the 2u raised to the n over n. Okay, then we know we can write here minus 1 to the minus 1, we know minus, so here minus infinite sum, and here minus 1 to the 2n, we know always positive, so here we have e to the 2un over n. Okay, now we can plug in here, so we can write now this is equal to 1/2 integral from minus infinity to 0. Now here square root of u and here minus sign, so minus square root of u. Instead of natural log of 1 minus e to the u, we can write infinite sum. So here infinite sum n is equal 1 to infinity e to the 2un over n du. Okay, then this sigma notation we can write outside of the integer sign. So here now we have minus infinite sum 1 to infinity, here n, here 2, so 1 over 2 times n, integral from minus infinity to 0. Now here is square root of u and here e to the 2un du. Okay, now to evaluate this integral, again we can take a substitution. So if we take 2 times u times n is equal to minus t, then differentiate, so 2n du is equal to minus dt, and also we can isolate the u is equal to minus t over 2 times n. Okay, now we can plug in here, so we can write now I is equal to here minus n is equal 1 to infinity, here 1 over 2n, 1 over 2n, and limit we know here minus infinity to 0, now infinity to 0, and here now square root of u, so we know square root of minus t over 2n, and then e to the 2un, so e to the minus t, so e to the minus t, and du is equal to minus dt over 2n. Okay, then we can simplify, so we can write here now minus infinite sum 1 to infinity, here 1 over 2n, here also square root of 2n, here 1 over 2n, so we can write 1 over 2n, here also 2n, here square root of 2n, and then here infinity to 0, we can change the limit, lower limit and upper limit. When we change the limit, this minus get cancelled, so here 0 to infinity. Now here minus 1, square root of minus 1 we know I, so here I we can write outside of the integral sign, and here we have now t to the 1/2 e to the minus t dt. Okay, then we can simplify. Now here we have minus infinite sum 1 to infinity, here I over now 2 times 2, so 4 times square root of 2 times n square times here n, so n to the 1/2, so n to the 5 over 2, here 5 over 2, and we know this is familiar with us because this is equal to gamma of 3 over 2. Okay, now we know theta function, so I'm going to write here we know theta function sum of 1 to infinity 1 over k to the s is equal to theta of s, so we can write this is equal to now minus I over now here 4 times square root of 2, now infinite sum into the 5 over 2, we know theta of 5 over 2. Also here gamma of 3 over 2 we know, the square root of pi over 2. Okay, now we can multiply by square root of 2, so we will have minus I square root of 2 times pi over, now here 4 times 2 8, 8 times 2 16 times theta of 5 over 2. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.